Hello, everyone. My name is Jake Hayfley, and today I'd like to show off my sound responsive LED strip project. As I've been doing all this stuff, I haven't found a really good name for it. It's kind of wordy. It's hard to put this in as text files or names on GitHub. It's kind of annoying. But yeah, so this is what the project is. I tried hooking. Here's the guy right here. I tried hooking him up a to the power supply and a cable in here and show off, have the lights go off as I'm talking and doing all this, but it was a little too bright for the camera to recognize a lot of it, so I ended up just having to just move it around, talk about it, which might be a little better because now I can give you guys an idea of it. But anyways, I guess I'll just kind of show off what I'm doing here. So here's the back of it. You can see the Arduino, the breadboard, and the sound sensor here, and then this little stand to set your phone on, so then your sound goes straight into the sound sensor. There's a lot of wires, and the ones that are bundled up with the craft wire are all different strips of LEDs. And so here's the front of it. As you can see, there's some hot glue, and this part kind of broke. That was because the print kind of had a little malfunction in the middle of it, but it turned out fine. Hot glue kind of saved my butt there, so it turned out good. But so here's the front of it. This design went through two different iterations. The front is the same, but the sides and the back are very different, and you'll see a little bit of that later. But this is it. I'll probably grab it and show it off a little more as we go. But I just wanted to give everyone a little bit of an idea of what it looked like, because it helps give context to what I'm talking about. And if you're watching this video, you've probably seen the demo. The demo is right above this on my website, or if you're on my YouTube channel, there will be a link to my website and the GitHub account in the description. So let's just get straight to it. The goals of this project, I want to create a box with holes in it so the LED strips could be placed on the outside of it and be fed into it, so then it could go to the code in the Arduino. The LED strips will be sound responsive based off of a sound sensor, which I ended up doing. I wanted to create a 3D CAD model of the box I'm planned on making. I initially planned on there being two parts, a box and a lid. Like I said, that did not end up happening because it was too time consuming. I wanted to also use a breadboard for the wires to kind of connect everything. This was very important because there were 9 different strips, so I had 9 different sets of 5-volt ground and digital pins, and they all needed to be in the breadboard because there was a lot of wires back there, and just having those all willy-nilly and stuff, it would have been a mess. So breadboard was good. And I want to make a hole for the power supply so the box is more permanent. You'll kind of see this in the first model. I wanted to make this back part covered, like as seen right here. But it was just too time consuming. I'll get to that in a bit. But I ended up just making it open. But I did design a version of it, which I still could have used if I designed it in different parts, but ended up not doing that. So section 1 was all about designing the project. One of the really important things when I was looking for parts for this was to find the correct power supply, because that is very important for your LED strips, because based on however many LEDs are in each strip, it will you need more power. And so there is a description in Amazon or for whatever strips you're buying for how much power each LED consumes. So then you just got to do some math. All right, well, I'm buying 120 LEDs. I ended up using 90. So what would be the max that I would need? And you want to buy more than your max that you need, just because you don't want the power supply to be running 100% at all time. You want there to be a little bit of range, just so it's not always running at full. So yeah. I also wanted to test the sound sensor with a single LED. So if you go to my GitHub and look at the code, there is a couple programs in there that are just using the sound sensor, testing little parts of it. And I want to get familiar with this code for using the sensor. And I want to draw up a rough 3D model to keep the breadboard and Arduino in. The LED strips go on the outside of it while threading the wires in. And so this is when I started using Autodesk Fusion 360 to model this stuff. So you can see in my first iteration here of the model, it is this kind of box structure, and then this piece at the top is actually a lid that is separate that I basically would have slid in and either Velcroed in. But that ended up using a lot of plastic for how big it was on my printer, and it was very time consuming for how long it was. There was a really high risk of just something malfunctioning since the printer's still new and I'm trying to like work out all the kinks and bugs in it and learn how the printer works. So just being new to that, I ended up having to shorten down on it, which you'll see later, or well, behind me. So section 1 reflection. I ended up using a 5-volt power supply because that's how many volts that the LED strips needed. There's 12 volt and 5 volt, and there's a lot of different types of LED strips. These ones are WS2128B, I think, or WS2182B, something like that. There's a parts list on my website that if you want to see what they are, they can. But this one had 10 amps and 50 watts. It was enough. They flicker a little bit without them being plugged into the laptop and the power supply externally, but it gets the job done. It was really hard to gauge how much I needed. I was kind of going in circles of like looking at this power supply and then these LED strips and this power supply and these LED strips, and there were so many different Amazon tabs opened, but yeah, it worked. It worked out. If it didn't work out, I could have just bought a different one and used this for some other project. And, you know, if I still want to get one that would be more consistent, I can. There's a lot of voltage loss in the breadboard since there's so many different pins going on in that. I try to get a capacitor. I put a capacitor in there to help try and keep it from flickering. It's not too bad, but if you look like really closely at it, you can notice a little bit. But it gets the job done. And I wrote a program to make the LED light up if the sound sensor went above or below a regular value. Like I said, this is in GitHub. I think I made... let's see, I'll pull it up over here. I have 6 different pieces of code in here. One just tests out an LED to make it blink. One tests the sound sensor. One tests a full LED strip. One tests 2 LED strips. I have the ocean pattern and then the final code, which was with the sound sensor. So, yeah, the way I kind of worked up with this project with getting familiar with Arduino and the different pieces was I would make code for the specific pieces and then work my way up to combining them and going on a bigger scale until I could apply them all into this guy. And I really like that way of doing it. I'm definitely going to keep doing that and learning the best ways to do that because I think it is a really methodical process in how I can learn how to do this stuff because it's really hard to figure out what's wrong when you just slap everything together at once and just try and write a ton of code. But if I just have just something isolated and then add another piece that was also isolated, it's really easy to pick it apart and understand what you're doing. And it's not too time consuming because like once I have the code written for the sound sensor, I can just copy it and put it into the sound sensor and one LED strip code and just kind of mesh them. And it's good to have these kind of individual programs because like I could use these for other projects and stuff. And it's a really good practice, I think. So yeah, that's my rant. I wanted to look for a library to break up the sound in octaves for better light mixtures for like different octaves. This didn't end up panning out. One of the things that I kind of had to shift directions with was the sound sensor. There's a difference in analog and digital reading. So a lot of sound sensors have one or the other or both, and mine had both. So you could either get the raw audio, the envelope, which detects the highs, and then the gate, which basically when it's a digital pen, it's either a 0 or 1 if it's basically hearing sound or it's not at all. And that's the one I ended up using. But the analog, what I wanted to do with the envelope was detect different values as they increased or decreased to make it more dynamic. And I wasn't consistently getting the same value, so it would be really hard to code it. So I ended up just using digital and setting the gain just right in there with a resistor so that I could make it more consistent. And so really all I have to do now is adjust the sound on my phone when it's placed on there and it'll react better, which is a lot easier because I don't have to plug into a laptop and adjust the threshold if I did it analog. If I did want to do it analog, I probably would have added some type of simple button onto the Arduino or breadboard to like increase or decrease the threshold by 5 so that if it wasn't gauging in the right range, I could just fix it on the spot. That would have probably been a fix, but at that point I was like, well, I know how to do it digital, so that's just how it is right now. But there's no saying I can't go back, because this one does have an analog read, and I could just add that pin in and then even have a toggle to do both of them if I wanted. So I could come back and do that. I had a lot of fun designing the CAD model. This is something that, while I was interested in 3D printing and getting excited to do this, I didn't realize how much fun I'd have with it. There's something really cool to me about just doing everything from the ground up. I really like the idea of designing like my own pieces and like just everything. I added a little extrude for my text, and so it says like made by Jake Hayflin here. I think that's really cool. I like being able to like kind of brand my stuff and be like, I did this. And it's really fun. 3D printer, I'm definitely, for my next projects, I'm going to try and break up the pieces and connect them with screws just so my printer can print the pieces faster, because if I have, let's say if I'm just trying to print like a cube, it would be a lot safer for me to just print out like 6 flat sheets on a cube if they're big enough, because I wouldn't have to worry as much about the print breaking, because if it broke when I was printing like the top of it, some part of the top of the cube, it might mess up. But then if I was just doing the different parts of it, then only that part would be messed up and I would lose less time in plastic. So that's something I'm going to consider in the future. I'm definitely going to be ordering like a bunch of not random, but a set of like different screw sizes, and then learning like screws and maybe like cylinders and circles and spheres and Autodesk Fusion 360 will be like my next CAD test. So I might even, before I do my next project, just try and get comfortable with like printing out like screw holes on just like little things. But I imported different parts to estimate the size better. This is one nice thing that's about CAD, is I could import the models for like my Arduino and my breadboard and my sound sensor into the design that I was doing, so I knew the dimensions were right. Because originally this box was a cube, and I got it down to a pretty good size to where if it was any more longer this way, it would just be wasted space and plastic. And so I decreased the footprint on this after I imported the models, because like, okay, I can like virtually half one of the sides of this thing, so I could save a lot of room. And the dimensions turned out really well. I mean, if this print, it kind of botched right here, but I'm really happy with how it turned out, and with the design. It was sturdy enough, like when I added this little triangle guy and then this support. Unless you're like really trying to break it. I mean, I don't even know if you still could. Maybe on this side because it's just hot glue here. But it's sturdy, and it's at about, I think I set it at 20% infill. So the outer layers, the like first 3 outer layers are solid, but then on the inside there's patterns of 20% that I think they're hexagon shapes in there, that basically fill in, so you don't have to use as much plastic. But it's really sturdy. We'll print out larger part is the box and the small part is the lid. Like I said, I changed that. I kind of like marking down my reflections and goals as I go through the project, because it's really fun to look back and see what worked and what didn't. Because like with the octave stuff and this, it didn't work out, but that's okay. I had to adapt, and I like being able to keep track of like what went well and what didn't, just so going forward I can be conscious of that and just be like, okay, well, I learned. But yeah, so section 2. The first part is all about designing. This stage was a lot about testing. So I wanted to find a library that would work well with the LED strips, and Fast LED was the one to do it. It was really easy to use, really nice. You just had to specify like how many LEDs you needed, how many strips, what type of LEDs, and you could define those all as like constants at the top of your code, as seen right here actually. So I made a 2D array of the CRGB type, where basically I set the number of strips and the number of LEDs, which are defined up here, and then I have the brightness set, and then I have the LED type set. And then in here I have it, so basically what you want to do is you call fast LED.add LEDs, and you want to put the type, the strip, the color order, and then the LEDs, which, since it's a 2D array in here, you have to call the first dimension of it, so then it can get to the actual LEDs, because the first dimension is actually the like strip basically. So yeah, and then you have to specify like pin mode for I call it sound gate here, but it's basically just the digital pin for the sound sensor. You have to set up the pin mode and say, okay, this is an input, like we're pulling information into the Arduino for it. Because if you were just doing a regular LED, you would say like pin mode, LED digital, comma, output. And then I also have a little code here to basically set up so the LED rainbows will start at the bottom. And I'll kind of go through this code a little more, but yeah, this part was all kind of about parts. I made sure the power supply is large enough. This was done through, basically, I just tested and plugged in both of the 60 LEDs per meter rolls. It was just a meter each, so it was 120 LEDs. I plugged both of them in the Arduino, put just the power supply in, and made sure they could all light up, and they did. So that's pretty good. Like I said, a little bit of voltage loss when I used the breadboard for all of them, but it worked. It worked out pretty well. So here is the kind of next step of pictures. So here's my new design here. When I realized that the box wasn't going to work out, I was like, okay, well, how can we do this better? I was like, we need a base and a top. And we still need a way for the holes to come in through the bottom. So I just left it completely open, except I had these little triangle guys on the side to help support this base, because it was the actual support on the sides here was pretty small. Because, like, you know, you can see here, if only like this little bit was here and there was no support on the sides, that would have been a pretty high risk of breaking. And, you know, that has all the LEDs and solder stuff on it, so I want to make sure that that stuff was like solid. So then I added these braces kind of at the top, because, you know, it's the top of it. Kind of just use logic there. Not a mechanical engineer, but like, you know, it's like, it'll work. And it, you know, if I was gonna like try and push on it and it broke, I was like, I can maybe try and print off like some more braces and put them in the middle here separately so I don't have to reprint it. But it turned out good. I don't know if there's like ways to test how durable it is or anything in any software. There probably is. Might be some for the future if I do stuff like this again, but I use logic. So then here you can see me testing one LED. This is the code basically to test it. So like this was kind of me initially writing the code because there's only 10 of them lit up. So I was like, okay, this is kind of to simulate if I only had 10 of them for one LED, just to get the code going. I didn't want to cut the LEDs at this point because I wanted to make sure that the 3D print would fit it. I measured them, but I was just to be careful because I didn't want to mess up the cuts, because then it would be really hard to like resolder like individual LEDs, or just, you know, I wanted to save myself a headache there just in case. And then I have this little phone stand here. And I'll talk about this a little bit, but so that's this little like flimsy guy right here. Like I said, the sound sensor is right under it right there, little microphone. And the purpose of this guy, like I said, is to put my phone on it. And yeah, so it was basically so, and I don't know if you can see it. Oh, you can't see it in the picture. You kind of can in the shadow. There's two little holes there where the iPhone X speakers are. If I was going to redo this, I'd probably make the whole thing a slit at the bottom, because I don't know how well it fit with other phones. But for mine, it works really well. Might be a design oversight. But it works. And it just plays the audio straight into the microphone, so I never have to worry about it being picked up or not. And that's also one of the reasons why I picked digital, because I don't have to worry about being picked up at this point. And I can just adjust the phone volume if it's too quiet or too loud. And to section 2 reflection, I use a 220 ohm resistors on the LED strip digital pins. So you might have noticed, but there's a whole row of resistors kind of on the inside there. Kind of in the middle between the two jumper wires. And so you need those with any LEDs. You need them with just regular LEDs, but you also need them with the strips. Not a ton, but you need them just to keep the Arduino and LEDs safe so they don't break. And the fast LED library makes controlling the LEDs very easily. Like I said, kind of walk through that. It's really nice. And so to talk about that a little more, here's my code for this. Basically, I do an if-else check. So like if you're getting volume, basically if it detects sound, then you raise the level of the rainbow colors by 2, and if it doesn't detect sound, it goes down by 1. And that is the code right here. And this if hasn't changed, or this if has changed. It's a Boolean value, and so basically I have this code so it It sets it so that you can control how often the LEDs would look for a change and update it. So I think right now I have it at 25 milliseconds, and it's a counter. So basically, it just makes it so I can control how fast it updates. Because if you didn't have that delay, it would be doing it every millisecond, and that is just really hard to look at. I think 25 is a really good number. I had it a lot higher before, but as I was actually playing music, I was like, this doesn't like sync up right. But 25 is pretty good. Maybe you could lower it to like 20 and you're still fine, but it's pretty close. But the nice part is, since it's defined at the top, it's really easy to change. Same with like the brightness or how many LEDs or strips you have, because you could either scale this project up or down and the code would still work. It is to an extent. I mean, I could probably add a for loop here and like make it. I think this is the only thing that's like kind of hard coded. But you could very, very easily scale this project up or down, which is something that I really like, because even if I want to come back to it or make a better version of it, then I could still use the code that I already have. Because if I already have code that works, I don't have to lose time on designing it again, which is really nice. Really nice. I feel like next year or maybe throughout the school year, I'll revisit a lot of these projects and go back on them and see like what I can do or how I can fix them up, because I've learned a lot already through like the last like 2 months of doing this stuff, and I really enjoy it. So I have two functions here called set white and set rainbow with white. Set white basically sets all the LEDs to white, and it does this by picking an individual LED by the strip number and the location vertically, and you can do this thing called CRGB and then these two dots and then white. I don't know what the symbol for that is. Yep. We're just going to leave that at that. And then you can also do this function called set hue, which basically it sets the hue. So a hue can be between 0 and 255, I think, or 254. And so that's how it gets the rainbow effect, because it'll constantly set the hue to that hue value. And the hue value is always going up and down between that scale of numbers, and that's how the actual color changes. And that's also set on a timer of 5 milliseconds. And because there's so many numbers to go through, it's shorter. But yeah, that one's pretty cool. And then at the end of everything, kind of like processing, you just call fastled.show, and this is what gets your LEDs to actually be displayed. So you always want this to be in your loop at the very bottom. You always want this shown, because the idea of it is you control, similar to processing and making games, you want to change the LEDs through different systems or loops or sensors or inputs in your code, and you want to make sure whatever happens, you always want to loop and show it again, because if it doesn't update, you won't see the changes. But it makes fast LED really easy to use, and it reminds me a lot of processing, and I'm very comfortable with that at this point. So it was a good fit for me. I really like it. So for one strip, I used a 1D array to control each individual LED. For multiple strips, I used a 2D array. So this is what made it. So I could basically use this one. Oh, where is it? This one. Here it is. LEDs like value to control every LED, because I had one dimension of it be the number of strips and one be the number of LEDs, and I could just control any of them from that point. And it made it really nice to use and control them, and a lot cleaner. And I wrote a function to turn every LED white and another change every LED to a rainbow pattern. Got ahead of myself and showed you that already, but yeah. And I ended up remodeling the CAD model, so it took less time and plastic to print, which I also already talked about. Section 3, putting it together. So I wanted to test out 3D printer. I talked about that a lot already. Print out the box. And I already, that was pretty simple. If you want to learn more about that stuff, you can go to other parts on my website for that section. But a lot of it with getting this to work was, since the dimensions of the base were so large, I had to make sure that the bed was leveled really good, so that it wouldn't be too close or be too far away. Because if it was too far away, then parts of it would peel off, and it would make basically building the top parts really hard, or just fail at some point, especially because the build was so long. But it worked out after a lot of trial and error. Having this project kind of up in the air kind of pushed me to get real comfy and familiar with my 3D printer, just so I could get this project going, because What I was waiting on for a couple days was to really get this print out, and I was just like, come on, like I want to keep going with these LED strips. But it turned out well. Then I wanted to Velcro the Arduino breadboard microphone. Velcro I got was really cheap. It just like didn't work. It was really weak Velcro. I want to use Velcro just as kind of more of a temporary thing, just if I wasn't sure how the box placement was. But I ended up using these adhesive pads that basically I use them for my LED cube too. I'm definitely buying some of these. I've had these from my college dorm and I love them, but they work really good for these projects because they're just wide enough to where they basically help it so that these soldered like pins from the bottoms of like the modules or Arduino don't touch the surface, and they're kind of hovering above it, but they're still like really good adhesion on the pads themselves. So it's great. I'm buying more of those. Printout phone stand, showed that off. That one was a really small print. I think I did it in like 2.5 hours. So by that point, I was working on parts of the box as it was going, and there was like a lot going on in the room because there was the stuff printing to my right, and then like LEDs going off over here, and it was just, it was really fun to watch, probably from an outside perspective. Stick the LED strips on the box. Right now, most of them are on just from the adhesion of the strips, but they've already kind of been coming off. The adhesion isn't very good, so, and I hot glued the first two because they really weren't working, but I think at some point I'll also have to bust out the hot glue gun and re-glue them, but that's not a huge problem. I'll also have to keep an eye on it. Solder. So the soldering on this one went really well. After the LED cube, I am a lot more comfortable with soldering, and I feel like I've learned a lot through trial and error, like I said before. And so I had to solder, let's see, so there's 9 of these and 3 pins on each, minus 6, so it'd be 27, 21. So I had to solder 21 pins, and they all worked the first time. They're kind of globby. There's a little more than probably you need, but it got it to work, and I'm getting closer to being better at soldering. I'm getting more comfortable with it. I also soldered the pin headers onto the sound sensor because it initially it just had like the empty holes. That is not the right side. Okay. And you can kind of see the like pin headers right there, where the wires come out. Those were not initially on there, so I had to buy some pin headers and basically cut them off of the big wide thing, and then I had to solder myself, and I'm a big boy. I did it. The LED cube has trained me, and honestly, after doing that thing, it doesn't feel tedious at all. I really enjoy soldering. It's really cool. I just love working with motherboards and modules and Arduino like this, and being able to do it on like an actual like board or like a module is really cool instead of just soldering the like LEDs like in the air. But yeah, I'm getting more comfortable with it. I might even design or print out some type of stand or something with clips to like hold different pieces together to make soldering easier. But I don't know how the soldering iron would do close to the plastic because it might melt. But if I have the like little crocodile clips I bought, it might be okay. That might be like a little small thing I do for a day. I don't know yet. Test the sensor ranges. Like I said, ended up doing digital values, so the range was just 0 or 1, not like the crazy analog stuff that I planned on doing. Not crazy, but it was, well, it kind of it was kind of crazy. It didn't end up. I kept reading the values as crazy because it was different stuff every time. But ended up working with how I did it, and then finalized the code. So here we go. I've been flipping around the box a bunch, but here's an actual like picture of it. And then here's a picture of the 2 patterns I made so far. So this first one, it doesn't want to have the full code up yet. If you want to see more of both of these, you can go to the demo video or watch it again if you've seen it. It's pretty cool. But so this is the one that lights up as more sound goes up. This is the first picture I took of it when I only had one LED program set up for it, but now I have all of them, as you see in the demo. And then this little guy, it was kind of hard to see on the video, but so what happens is, that's called like the ocean pattern. I don't know. I just thought of this one. I was like, oh, okay, it'd be kind of cool. I just wanted to test out using fast LEDs more without the sound sensor. And so I have like a little sun here, some water in the sky, and then these little raindrops come down, and when they hit right this layer above the water, it basically sends little ripples going across. And it's basically random at whenever each the little rain droplets where they come down, and then wherever it's at, the ripples will go across. And that's really cool. I liked using the random function and just making it kind of like pretty to look at. Like I said, I planned on having that running up right here, but didn't work out. But it's okay. It was too bright. If you want to see more of that, you can go to the demo. And I hope to design more patterns of it. That might be like something fun to do at school. I'll probably take this thing to school with me next summer or fall semester and play around with it more. So to reflect, after reworking the CAD model, I had much faster print. Had to add the phone stand, use the adhesive pads, solder the wires, use the adhesive on the LED strips to stick them in the box. Sound sensor's finicky. Plan on adding more LED effects, and like I said, I used a resistor on the sound sensor to make the gain lower, and this was so when the phone was right above it, it had the like just right amount for the digital values to work, and it worked out really well. It was a good quick fix. And I'm realizing that in all these videos, I'm talking about the reflection before I get them, and then I just kind of like mumble through the same stuff again. Maybe I should put these first before the pictures or something. I don't know. It's just kind of so I don't miss something. But so overall, I had a lot of fun with this project. Being able to connect the designing part of it with the electronics and code was really, really cool. I feel like I can really make things the way I want to now, and I'm not binded by whatever I can kind of scrounge up to put it all to. So I think getting a 3D printer was a really good move. I love it. It's a really cool hobby. I think it's going to be something that I kind of just stay into for a long time, even just without Arduino. It's just really fun to print things off and design them. And this is kind of one of the projects that pushed me to do that. But I don't know. I just keep thinking of like really fun ideas to do. Learned a lot about input output with the sound sensor versus the LED strips. This was something we did a lot in my first computer engineering lab or class when we learned how to code C. We would have PlayStation 4 controllers, and there was a sound sensor in them that we basically had to detect different values and then put different outputs on a console based. We'd make like different games and stuff with the buttons and controllers. And this reminded me of that a lot. And so that was kind of a good callback. And it was nice to kind of apply what I learned in that to my own stuff. I can't believe that by this point last year, I didn't know how to code at all. And the stuff I'm doing now just like blows my mind. Like if I showed all this to me not long ago, I don't know, just before I knew how to do all this stuff, I'd be like, no way you can do that. But it's really cool. I am loving how much I'm learning with this stuff, and I hope I can keep doing it. Like I said, using the LED strips like this has given me a lot of ideas to apply to future projects, and they're really easy to use. I'm sure that I was talking about developing some type of RC car with a buddy or doing something along those lines. And I'm like, well, if we can strip in or like squeeze in some LED strips on the bottom of the car to backlight it, like it'd be easy. So I'm sure Amazon is going to be getting a lot of orders for those for me. Probably try and squeeze in a lot of projects with those. Those might be my like go-to thing to just like print off something small, put like an Arduino Nano, like a small little guy, and maybe like some small batteries in it, and just just have fun with it. See what I can do. Plan to add more patterns in code that will not be tied to the sound sensor and look pretty. I already did one of those. I might do one that's kind of like lava-y. And I don't know. I see a lot of like cool color and effect stuff for like keyboards that people have, so I might try and apply some of those ideas to it. Having this like grid of LED strips though is a really nice thing to have, because if I want to mess with LED strips for other projects, I can go to this and kind of test it first without having to either buy more LED strips to make sure it works or just play around with it before they get here for my order. So this went on longer than I thought. I ramble a lot. But thank you for whoever's watching this and listening. I am really enjoying these projects. I don't know how many more of them I'm going to be able to squeeze in this summer. But at the rate I'm going, it makes me really hope that I still have time for this stuff. As I've been doing these more and more, that's kind of just become more of a um, cool down, like chill thing for me to do when I'm done with things like school or just just chores or like whatever I'm doing in the day. Um, and I've because I've always like loved video games, done that, but this is kind of turning into my like downtime, like video game Netflix time, which I think a lot of people might be like, how is that like relaxing for you? Because and sometimes it isn't, but like when I solve something or I just like finally find a solution or a fix or like some type of design, it's really satisfying for me. And I think that the payoff for it is a lot more than playing video games or watching shows. I think it's a lot more rewarding to me because this is stuff. It's keeping my coding skills up, but it's also just really cool. I had a really nerdy like geek out reaction when I saw my LEDs light up the first time. I kind of wish I recorded it. It was really funny, but like parts like that, it's really fun. I'm kind of on a roll right now. I feel like with like just knocking these out of the park. I won't be able to like do stuff at this rate during school, but I'm hoping I can just kind of like scrounge up like parts that I have and just like mess with stuff, get an idea. I'm definitely going to be keeping a solid list of stuff to do next year. I honestly just like can't wait until I have just more experience coding and knowing more. I haven't really messed with Raspberry Pis that much, but that might also be something to look into. And yeah, I haven't really done many software projects in the last month, but I might just do like one more thing in processing, like design like a calculator app or something if I'm waiting on parts to come or if I just have time. But yeah, so thank you for anybody watching and listening and keeping up with this stuff. It's been really cool. I've been able to document all of it like this. Because this will be a very good reference for me to go back on and to keep track of all this code and have this website to show off to anybody who's interested. So, thank you, and I hope that I add more to this website soon. The sooner the better, because that means I got some other crazy project done. Looking to do something with like motors and RC cars next. I kind of want to do something where like a really small robot will follow a black line like on a wood or cardboard with like a Sharpie. So I'm probably going to look into that after I stop recording this video. But yeah, thank you. I've rambled for probably a little too long now, but thank you for watching. Bye.